Imagine you're on a raft, adrift in a vast, dark ocean. The stars are your only companions and the water stretches out endlessly in every direction. Everything seems calm, serene even. The surface is smooth, reflecting the faint light above. But then, you notice all the other rafts, scattered across the water, all drifting in the same direction, almost as if guided by an unseen hand. There's no wind to fill a sail, no visible current disturbing the glassy surface. Yet some unseen force is pulling everything inexorably toward an unseen shore. This isn't a scene from science fiction, it's a metaphor, a way to visualize a real phenomenon in our universe. On the grandest scale imaginable, across billions of light years, entire galaxies, including our own Milky Way, are being relentlessly tugged toward a mysterious, invisible destination, a cosmic shore we cannot see. We call this enigmatic phenomenon the dark flow, and it represents one of the most profound and perplexing puzzles in modern cosmology. This isn't a subtle, gentle nudge, it's a powerful, persistent, and incredibly strong pull, acting across vast distances. Entire clusters of galaxies, massive structures containing hundreds or even thousands of individual galaxies, each galaxy itself containing trillions of stars and countless planets, are streaming together through the cosmos at millions of miles per hour, an astonishing cosmic ballet. This coordinated motion is happening above and beyond the expected expansion of the universe itself. It's like dots painted on a balloon, not only moving apart as the balloon inflates, but also sliding in one particular direction across the surface, as the balloon continues to inflate. So, what could possibly be powerful enough to move so much matter on such a scale? The truth is, we simply don't know. The gravitational force seems to be emanating from beyond the edge of our observable universe, from a region of space that, by definition, we cannot directly observe. The term dark flow perfectly captures the essence of this mystery, a vast invisible current shaping the movements of galaxies across the cosmos. It's not being caused by a single supermassive black hole, nor is it likely due to a hidden, exceptionally large supercluster of galaxies within our observable range. The source is either located so far away that the light it emits simply hasn't had enough time to reach us since the beginning of the universe, or, even more intriguingly, it's composed of something that doesn't interact with light or other electromagnetic radiation in any way. It's a ghostly gravitational anomaly, a phantom force exerting its influence across billions of light years, hinting at a universe that is far more complex, interconnected, and mysterious than we previously imagined. This profound discovery challenges the very limits of our current perception and understanding of the cosmos. We're like cosmic detectives meticulously gathering evidence, piecing together fragmented clues from the faint, ancient light of the cosmic microwave background, and by carefully tracking the subtle, complex motions of distant galaxies across vast stretches of space. The dark flow serves as a tantalizing cosmic fingerprint, a clear indication of something significant, but the identity of the culprit, the source of this gravitational pull, remains frustratingly missing. Its existence shakes the very foundations of the widely accepted Big Bang model of cosmology, a model that has been remarkably successful in explaining so much about the origin, evolution, and structure of our universe. This perplexing anomaly strongly suggests that our current cosmological model, as comprehensive as it may seem, might still be fundamentally incomplete. It hints that there could be an entire, undiscovered chapter in the cosmic story, a chapter we haven't even glimpsed yet. One that begins just beyond the limits of our current observational capabilities, just beyond our sight. Ultimately, the dark flow reminds us that the universe may be far stranger, more wondrous, and more full of surprises than we could have ever imagined. How did we stumble upon this hidden cosmic river, this enigmatic flow that defies our conventional understanding of the universe? It all started with the cosmic microwave background, or CMB, the faint afterglow of the Big Bang, the very echo of creation itself. This ancient light permeates the cosmos, offering a glimpse into the universe's infancy. The CMB fills all of space, appearing nearly uniform in temperature, but upon closer inspection, subtle variations emerge like ripples on a cosmic pond. As galaxy clusters, those colossal congregations of galaxies move through space, they interact with this ancient light, leaving their mark upon it. This interaction leaves tiny temperature shifts in the CMB, a cosmic speed camera capturing the motion of these galactic behemoths. A dedicated team of astronomers led by Alexander Kashlinsky embarked on a quest to decipher these subtle temperature variations. They meticulously used this effect to measure the motion of hundreds of galaxy clusters spread across vast cosmic distances. According to the standard cosmological model, the prevailing theory that governs our understanding of the universe, these motions should be random, a chaotic dance of cosmic objects, averaging out on large scales, with no preferred direction. But as the astronomers delved deeper into the data, they uncovered something truly shocking, a deviation from the expected randomness. The clusters weren't moving randomly as predicted by the standard model. Instead, they exhibited a collective, coordinated motion, flowing in a single, unified direction, hurtling through space at astonishing speeds, exceeding 2 million miles per hour. It was as if every person on Earth suddenly and inexplicably leaned the same way at once, a truly bizarre and unexpected phenomenon. The odds of such a coordinated movement occurring by chance were statistically impossible, defying all expectations. This unexpected discovery marked the first tantalizing evidence of the dark flow, a mysterious current shaping the cosmos. Intrigued and determined to unravel this cosmic enigma, the team expanded their survey, peering deeper and deeper into the vast expanse of space, and to their astonishment, the signal persisted, growing stronger with each observation. The accumulating evidence pointed to a consistent, large-scale flow of matter, an unseen river coursing through the universe. This flow extended across a vast swath of the observable universe, dwarfing the size of our local galactic neighborhood. This wasn't merely a local anomaly, like our own Milky Way galaxy being gravitationally pulled toward the Virgo cluster, a nearby group of galaxies. This was a cosmic current of unprecedented scale, stretching billions of light-years across the cosmos, relentlessly carrying everything in its path toward an unknown, unseen source, a mysterious attractor lurking beyond our cosmic horizon. The universe, it turned out, was not the serene and placid place we once imagined, but a dynamic and turbulent arena of cosmic forces. The groundbreaking discovery of the dark flow forced scientists to fundamentally reconsider what they thought they knew about the underlying principles governing cosmic motion and the large-scale structure of the universe. The dark flow rapidly became one of the most intriguing and perplexing mysteries in modern astronomy, captivating the minds of scientists worldwide. And it raised a profound and unsettling question that continues to challenge our understanding of the cosmos. What could possibly be the cause of such a vast coordinated movement, orchestrating the motion of galaxies across billions of light-years? The dark flow discovery sent ripples of astonishment through the scientific community. It was a finding so unexpected, so contrary to established models, that it forced researchers to reevaluate some of their most fundamental assumptions. Because it directly contradicts the cosmological principle, a cornerstone of modern cosmology. This principle asserts the universe, when viewed on a sufficiently large scale, is essentially uniform, meaning it looks statistically the same in every direction we observe. This principle is the very foundation upon which the Big Bang model is built, providing a framework for understanding the universe's evolution. But the dark flow, with its galaxies moving in a somewhat synchronized manner, points to a preferred direction in space, an alignment that defies explanation. Effectively shattering the idea of isotropy, the uniform distribution of matter and energy in all directions. If the dark flow is indeed a real phenomenon, it implies something is fundamentally different and unique about that particular region of the universe, challenging our understanding of cosmic structure. Our current understanding of how galaxies formed and clustered together relies heavily on the assumption that the universe was remarkably uniform in its early stages, with only slight density fluctuations. But a massive, coherent flow of galaxies across vast cosmic distances strongly suggests that the initial conditions of the universe weren't entirely random as we previously believed. While gravity is undoubtedly the architect that shapes the large-scale structure of the universe, on scales larger than a few 100 million light-years, where structures should be evenly distributed, its effects, statistically speaking, should more or less average out, leading to a state of equilibrium. Yet, the dark flow stubbornly persists, remaining constant in its directional movement, as far as our most advanced telescopes and measurement techniques allow us to probe, extending out to at least 2.5 billion light-years, a truly staggering distance. Whatever unseen entity is causing this gravitational pull must be absolutely gargantuan in scale, dwarfing any known structure within our observable universe, a cosmic leviathan beyond comprehension, and potentially residing entirely outside the boundaries of our observable universe, forever beyond our direct detection. It's as if we're feeling a gravitational whisper, a subtle influence from something vast and unknown. The dark flow isn't just an unexpected discovery, it appears to fundamentally violate the very rules and principles we thought governed the behavior of the cosmos. It strongly hints at the existence of new physics, forces, or dimensions beyond our current understanding, or perhaps a vastly different cosmic geography, a universe structured in ways we haven't even begun to imagine. The universe may be hiding secrets, vast and profound, on a scale so immense that it challenges the very limits of our imagination and comprehension. Where is this cosmic river flowing? The data points to a patch of the southern sky between Centaurus and Vela. Billions of suns in hundreds of thousands of galaxies are being dragged toward this spot, at the edge of our observable universe. This direction is near the Great Attractor, a known gravitational anomaly. But the Great Attractor isn't massive enough to explain the pull. The dark flow is much larger, pulling even the Great Attractor itself. It's like discovering your local current is part of a massive ocean stream. The source must be far more distant and massive, beyond our observational reach. The dark flow could be the first evidence of structures in the vast, unseen cosmos beyond our horizon. We feel the tremors of something colossal just out of sight. Faced with the dark flow, scientists have proposed bold theories. The simplest, a massive concentration of matter just beyond our cosmic horizon, an unimaginable supercluster or filament. But the standard model doesn't easily allow for such giants. It would mean our universe is not a typical sample, but a cosmic neighbor to one of the biggest things ever. Others suggest the dark flow is a relic from before the Big Bang, an imprint from a parent universe or a pre-inflationary era. If true, studying the dark flow could give us clues about reality before time itself. These ideas are speculative, but the mystery demands we consider them. The universe might be whispering its origin story through the motion of galaxies. Extraordinary claims need extraordinary evidence, and the dark flow has faced skepticism. Some scientists argue it could be a statistical fluke or a data error. The Planck satellite, with higher precision than WMAP, found no significant evidence for the dark flow. This sparked debate. Did Planck miss the signal, or was the original discovery just noise? The original team stands by their findings, but others question the methods. Resolving this is a top priority for researchers. The lack of confirmation from Planck is a major blow. Future surveys will be needed to settle the debate. For now, the dark flow remains a tantalizing, unproven mystery. Suppose the dark flow is real, what else could cause it? One idea, the gravitational pull of another universe, a neighboring brain in a higher dimensional space. Gravity might leak between universes, tugging ours toward a parallel world. Or perhaps extra dimensions of space are warping our universe, creating a large-scale flow. These theories are speculative, but they arise from serious attempts to unify physics. There's no direct evidence for other universes or extra dimensions, yet. The dark flow could be our first observational clue that reality is far stranger than we imagine. It forces us to ask, what if the universe is not only bigger, but stranger than we can conceive? So where does this leave us? The dark flow is one of cosmology's great unsolved mysteries. On one hand, evidence suggests a vast, coordinated motion of galaxies that defies our standard model. On the other, our best instruments find no proof, suggesting it may be a phantom in the data. The scientific process is working. Claims are tested, debated, and refined. Whether real or not, the dark flow pushes us to question assumptions and imagine new possibilities. Mysteries like this drive discovery, inspiring bigger telescopes and bolder theories. Upcoming surveys will map the universe with unprecedented detail, perhaps confirming or denying the dark flow. For now, we wonder. Look up at the night sky and remember, our galaxy and countless others might be on a journey toward an unknown destination. The greatest chapters in the cosmic story are still unwritten. The universe awaits. Keep looking up.